Alrighty, let's look at taking some data and um, creating an interpolating polynomial in Desmos. It's pretty straightforward. So you need to enter your data. If you go here up to the right, add item, you can add a table. Now it will typically do x1, y1 for the table, the first table you try to make. Now if I go down here and I say, well, add another table, it goes to x2, y2, and all that. Now if you don't like those names, you can change them. Now I would not change them to just x and y. I wouldn't usually use a t or an r. So x, y, r, t, I would never tend to use those. Now you could use uppercase letters though, and so for instance here, if you wanted to go uppercase x and an uppercase y, that would be fine. It recognizes the difference between upper and lower case, so uppercase x and y, not a problem. Also, I wouldn't use e because e is the number e. Okay, so let's enter some data. Suppose I just have 0, 1, 2, 3, and say my y values are 5. Notice it starts plotting. 1, -1, and 5. Okay, so here you can change the view. You can pan around, grab it with your mouse, and do that. Zoom in and out. Now you may need to mess with, say, the x-axis more than the y-axis to look at your data, or vice versa. So if you click on the wrench, you can come in here and change those. So the y-axis looks pretty good here. X-axis, maybe I want to change that to -1 to 4 or something like that. So I could go -1 to 4, and then just click outside of here, and now my data fill up the space a little better. Okay, but I have my data. All I have to do is give it the model I want using the variable names up here. So y, and it tells me I've got a 4-element list. Now, instead of an equal sign, use a tilde. Okay, that's that little squiggly thing. It's also called a twiddles. I think that's like Great Britain calls it a twiddles, but we call it a tilde. And then I have 4 points, so my interpolating polynomial should be a cubic. And so I could, do something like, and it doesn't matter whether I start with the cubic part or the constant part, so suppose I said A0, and then plus constant A1, make sure I get my uppercase X, and there you go. See, it made a straight line. So it's actually right now doing least squares, but if I give it the correct degree for my polynomial, it will do the interpolating polynomial. So now A2, whoops, forgot my plus sign, plus A2 x squared, and then plus A3 x cubed. And there we go. There is the interpolating polynomial. Goes through 0, 5, goes through 1, 1, down here to 2, whatever it was, -1, and then 3, 5. So that's my interpolating polynomial. It gives me the parameters here, so A0 is 5. And, I can check this then by doing, I could go here and say y equals, and actually I can either use the A0 or the 5. So I can say A0, it knows what that is. See, it says y equals 5. X, oops, not x, plus A1 x plus A2 x squared, and then plus A3 x cubed. So so you see I get exactly the same thing, but this is now my Desmos function that I can manipulate. I can do things with. For instance, if usually when I do this sort of thing, I'll change to an x. So I could say f of x, and then I could plot its derivative. I could plot its second derivative, put another thing in there. Second derivative, straight line, right, the cubic. Second derivative should be a straight line. And if I go to the third derivative, I should get a constant. Third derivative, now I got a constant of 6. And so, I can do that sort of stuff if I define that function that way. But I can't do it, at least I don't think I can do it with this stuff up here. I have to redo it down here. But again, if I say y equals, and I just read off those numbers, 5, plus, or actually minus, I guess, minus 3x, and then minus 2x squared, and plus x cubed. And you see I get that same function now in black. If I turn these off, I can see these other functions. Okay, but that's all there is to finding that interpolating polynomial. Give it your data. Now if I go back to calling these like x1 and y1, there's no reason I couldn't do that. Of course, now this is very confused because it doesn't know what these things are, but there's my y1. And if I change these all to, whoops, x1, x1, and x1, there we go. I'm back to that same solution. So it really doesn't matter, what the names of these things are. I can do that. Okay, and if I wanted to add, say, the same x values but different y values for a different function, all I have to do is go in here, and if I right arrow, so it makes a new one. And if I'm calling these x1, y1, maybe I would either call this y2 or z2 or something like that. And I can put some more data in. Let's say this is 3, 2, 5, and -1. Okay, so I can do that. And then what I can do now, if I highlight all that and I do a Control-C for copy, and then I just click here, enter to make a new cell, and I paste, Control-V. But now, just go in, since the x's are all the same, it's just different y values, and I do the z1, and oh, well, that's very, I did not expect that. Z1, I'm trying to think what happened here. A cubic should fit it. Well, this is what happens when you just, oh, well, that is weird. Notice the parameters. It's got Z1 here. Oh, I wrote Z2. Z1, much better. Okay, and so you look at it for a little while, you might figure out what went wrong. But yeah, so there's the Z1. If I get the name right up here, see, they have to match, otherwise it gets very confused. But so I did that. There's another function with those same x values, but different y values, and I can get them both on here at the same time, and I can do my data this way. So there you go. That's really all there is to using Desmos to get your interpolating polynomial. You can use anything from 2 points to probably 100 points. That wouldn't be really good, most likely, but indeed you can do that. So there we go, interpolating polynomial with Desmos.